All right, so we are looking at 17.2 law of sines, day 2. Evaluating triangles when SSA is known information. You guys talked about congruent triangles last year in Math 2. SSA is when you have two triangles and the sides are, two sides are congruent and the angle in between is congruent. We do, actually, the two sides are proportional. So we're going to work with that, and there's a few things we'll talk about on how to determine some stuff. But basically, we want to first figure out a few things and then determine how many possible triangles there could be to be able to determine how many different ways we can go about it. So in this case, we have each triangular wing of a model airplane has one side that joins the wing to the airplane. The other sides have lengths B equals 18 inches and A equals 15 inches. The side length B meets the airplane at an angle A. So here's B meeting at angle A, and it's 30 degrees. And meets the side with length A at point C. Meets the side length of point A at C. I think I wrote that right. That doesn't sound quite right, but meets the side with length A at point C. We're going to find each measure. So the first thing we want to do is determine how many possible triangles we have. Since A is acute, if we actually come all the way down to the other end of our board real quick and look, to determine the possible number of triangles, if A is right or obtuse, then we follow this rule. But A is 30 degrees, so that makes it acute. And so we have to figure out what H is, because if H is equal to A, or A, side A is greater than B, then there's one triangle. But if A is acute and A is between H and B, then there's two possible triangles. So the bottom line is we know that A is acute, we got to figure out what H is. H stands for height. So we're going to have to drop in a perpendicular from C straight down. Now, if we do that, I have some value of H here. This is a perpendicular, and I don't know what it is. I do know that I got to figure out what H is. H will help me determine how many possible triangles we've got. So to do this, I'm going to simply use trig, the right triangle trig. This is the opposite, this is the hypotenuse. Opposite and hypotenuse means I'm going to say the sine of 30 degrees equals H over 18. Put a 1 under here and cross multiply. That's 18 times the sine of 30 equals 1 times H. So you plug into your calculator, you end up that H is 9. So if H is 9 and B is 18, remember A is 15, we're going back over here to the other side of the board real quick to look at our rule. So we have that H is 9, A is 15, and B is 18. We know A is acute, so looking here, H does not equal A. A is not greater than B, but here, H is smaller than A, and A is smaller than B, so we've got two possible triangles that can happen. So we don't know exactly which case it'll be, but I do know that there's two cases of them. I'm going to go ahead and draw my two cases out. We have two possible triangles, the first of which can look like this, where this is A, this is C, this is B1. We're going to call it B1 because that is our, that looks more like an A. And then we have our second situation that A can be this way, and B2 can be here. This could be still 30 degrees. There's A. There's 18, and there's C, and H would be here at 9. So two different situations. We have to count for both. We are looking for the measures that are missing. So the first thing we want to actually figure out is we want to figure out what B1 or B2 can be. So law of sines. I have 30 degrees, 15. I need to know what angle B is, and the 18. Law of sines, sine of 30 over 15 equals the sine of B1 over 18. Cross multiply. And I have 18 times the sine of 30 equals 15 times the sine of B sub 1. Divide out the 15. So 18 times the sine of 30 divided by 15 is equal to the sine of B sub 1. Now remember, we have to actually take the inverse sine of both sides to get rid of the sine. And when you do that, you should get B sub 1 to be approximately 36.9 degrees for that angle. Then we're going to head over to find what the other one would be. So if B sub 1 is 36.9, that forces, if we look, and you remember about your geometry, the angle has to be the same. Side, side, angle. So the angle has to be congruent. The sides are proportional. Or not congruent, sorry. They have to add to 180. So 180 minus the 36.9 has to be our B sub 2 value, which means the B sub 2 is going to have to be, what is that, 143.1 degrees for the other B value. So I have that in both. Now, we're going to finish both problems. If I know two angles of a triangle, I can easily find the third. This is 36.9. So that means 36.9 plus 30 degrees plus angle C has to equal 180. That's 66.9 plus measure of angle C equals 180. So the measure of angle C ends up being let me take my cheat sheet just so I don't make a math error, 13.1 degrees. I'm going to do the same thing and find angle C for the other one. Over here, I know 143.1 plus 30 plus the measure of angle C has to be 180. When I add these two together, I get 173.1 plus the measure of angle C is 180. This leaves this measure of angle C on this triangle to be 6.9 degrees. That's a very small angle. Okay? Now, we need to find side C. So let's look at finding side C. For this one, I need to know side C, which means I'm going to have to use this angle up here of 113.1. And we say the sine of 30 over 15, because we're going to use that one that we didn't round and we know exactly, equals the sine of 113.1 divided by C. So when you cross multiply and divide, let's just cross multiply. Sine of 30 equals 15 times the sine of 113.1. Divide out the sine of 30. That leaves me with C, the side of C being 27.6 when you punch it into your calculator. Now, finding C over here, again, we have this angle, which is 6.9. We know that side A has to be 15. We need to figure out what this side is here, side C. So again, we say the sine of 30 over 15, using the values that they gave us, has to equal, let's see if I can move the board down just a little bit more, must equal the sine of 6.9 divided by sine C. So C times side of 30 equals 15 times the sine of 6.9. Divide out the sine of 30. So C is equal to approximately 3.6 inches. So when we get two triangles, we have to account for both. There will be cases that we have only one. Please make sure you've written this little chart over here down where it tells you how to determine the number of possible triangles. Please make sure you've written the word problem down, and we'll practice them tomorrow.